Today we're going to talk about the Earth's tilt and the seasons. Behind me is a diagram. We have the sun in the center, and around that we have the Earths at different times of the year. Now it turns out that this is obviously not to scale, because you could actually put 1 million Earths inside the sun. So big difference in size there. Now let's begin by drawing an axis through the Earth. So there's an imaginary axis through the Earth. And I'm going to take this pointer and I'm going to put it like that. And the Earth actually rotates around an axis. But that's not the whole story. How did the Earth actually begin to rotate? Well, it turns out a long time ago, all this was just a big cloud of dust and gas. A big whirling cloud of dust and gas that was set in motion from the beginning of the universe. Big Bang Theory. Now, as this gas and dust coalesced, came together, and it did so because of gravity. Gravity pulls things together. As all that dust and gas coalesced, it formed the Earth. It formed our solar system, actually. And as that whirling gas came together, it all got squashed together into the Earth. And it continued to spin because of conservation of momentum. And that's why the Earth actually spins. It turns out that the Earth actually was spinning about once every 10 hours back when the Earth was formed. It has actually slowed down because of the pull of the moon. Now we only spin about once every 24 hours. That's how fast we rotate now. On top of that, it turns out that the Earth's axis is not vertical. It's actually at an angle, about 23.5 degrees. So I'm going to go ahead and I'm going to draw that angle in here. There it is. And I'm going to exaggerate that just a little bit. 23.5 degrees. Now, how did it get like that? Well, it turns out that over the time when the Earth was forming, there's a lot of big chunks of rock out there. And some of these big chunks of rock crashed into the early Earth. And it's thought that some of those big chunks actually knocked the Earth off its axis and into the axis it is today, about 23.5 degrees. So the Earth actually rotates around this imaginary axis like this. Now, let's go ahead and I'm going to draw an imaginary axis here, an imaginary vertical axis here, and an imaginary vertical axis here. And let's go ahead and draw the actual axis of the Earth. And I'm going to go ahead and I'm going to draw the equator. So there's our equator. Remember, everything's been rotated 23.5 degrees. So there's the equator. The equator is going to be in red. There it is. The equator's in red. There it is. And there it is. Well, let's just go ahead and label that equator. There it is, right there. And on top of that, I am going to go ahead and draw the Tropic of Cancer and the Tropic of Capricorn. Again, Tropic of Cancer, Tropic of Capricorn. Tropic of Cancer, Tropic of Capricorn, Tropic of Cancer, Tropic of Capricorn. And we're going to use those as reference points. Now, let's assume that we live right here on the Tropic of Capricorn. I'm going to put a great big dot there. Let's assume that's where we live. And the sun shines on the Earth, so I'm going to show a ray of sun coming from the sun going to the Earth. Now, if you lived on the Tropic of Capricorn, as the Earth rotates, you're going to get direct sunlight from the sun. No angle here. And because of that, you're going to be nice and warm, especially in the summer. So let's call this the summer. Now let's go over here at the opposite time of the year. This would actually be the winter over here. And let's go ahead and draw our same ray of sun. There it is. There it is. And remember, you're going to live up here. on the Tropic of Capricorn. But notice the sun doesn't shine directly on you anymore. It shines on you at an angle. And because the sun shines on you at an angle, you don't heat up quite as much. We talked about this in a prior video called unequal heating. There's a couple reasons why if you live up here, you're not going to get as warm. And it turns out that the angle of the sun is going to be most extreme during our winter. Down here, this would be fall, and this would be spring. In fall and spring, the angle that you're at is about halfway between this extreme and this. So you don't get quite as cold, but you don't get quite as warm either. So the seasons on Earth are actually due to the tilt of the Earth. Now we're lucky because the tilt is not too extreme. If the tilt was too extreme, we'd have more extreme summers and more extreme winters. If there were no tilt whatsoever and the Earth rotated around a vertical axis, then the equator would be about the same temperature all the time, which it pretty much is today. But as you got further and further north and south of the equator, you would get cooler and cooler and cooler, and you wouldn't have those seasonal variations. Whatever temperature you were at, that's the temperature it would be pretty much all year long. There would be no seasonal variations. So we're very lucky that the Earth is tilted just enough, because if it was tilted even more extreme summers, more extreme winters. If the Earth was tilted less, then you would have no summer and no winter. You'd have one season all year long. And that's going to be it.